Good day, everyone. I am Jadvil Yasaran from Bachelor of Secondary Education, major in Science, Section 1-2A, and I am assigned to discuss to you the methods of expressing concentration of solutions and also colligative properties of solutions. First, percentage by mass. The percent by mass is the mass of solute divided by the total mass of the solution multiplied by 100%. Second, percentage by volume. The percent by volume is the volume of solute divided by the total volume of the solution multiplied by 100%. Number 3. Mole fraction. To calculate the mole fraction of solute by dividing the moles of solute by total number of moles of substances present in solution. Calculate the molarity of the solution, moles of solute per liter of solution. Number 4. Molarity. Molarity means that you can find the molarity of a solution if you know the total number of moles of the solute and the total volume of the solution. So, in order to calculate the concentration of a solution, in molarity, you need to divide moles of solute by total volume. Number 5. Molality. Molality or molal concentration is the amount of a substance dissolved in a certain mass of solvent. It is defined as the moles of a solute per kilograms of a solvent. And lastly, parts per million or ppm. It is calculated by dividing the mass of the solute by the mass of the solution, then multiplying by 1 million. Both parts of the equation must be in the same format, weight or volume. Now, let's proceed to the formulas of the methods of expressing concentration of solution. First, percentage by mass or weight over weight percentage equals weight of solute divided by weight of solute plus weight of solvent or solution times 100. Percentage by volume is just the same by the percentage by mass. The only difference is that we will take the volume. The formula for percentage by volume is volume divided by volume percentage equals to volume of solute divided by volume of solute plus volume of solvent or what we call solution times 100. Mole fraction. This is the most important thing that we should learn because it has various concepts in it and various formulas in it. So before knowing what is both fractions, we should know first what is mole, and as we know, there are two components, that is solute and solvent. So the number of moles will be also distributed for the both of them. That is, mole fraction is denoted by X. Before describing both sections, we should know each and every value present in it. And what are those? They are number of moles. And what are number of moles? The number of moles are distributed for two parts, that is for solute also and solvent. Let us see each one by one so that the first one is number of moles of solvent can be described by Na, where N is number of moles and A is for solvent. So therefore, the number of moles means weight divided by molecular weight. This is the formula that we know, but instead in this case, we are distributing A and A means we are Na number of moles of solvent and B number of moles of solute. The formula for molarity is M equals to number of moles of solute divided by volume of solution in dm cubed equals to number of solute divided by volume of solution in dm cubed equals to weight of solute divided by molecular of solute times volume of solution in dm cubed. The formula for molality is M equals to number of moles of solute divided by weight of solvent in kilogram equals number of solute divided by weight of solvent in kilogram equals to weight of solute divided by molecule of solute times weight of solvent in kilogram. Parts per million or ppm. These units are taken for those substances whose concentration is very less. For example, you cannot distinguish the amount of oxygen present in seawater because the seawater consists of 5 to 6 grams present in 1 million of water. 1 million of liter of water, so therefore we are describing it as this way. The formula for parts per million is ppm equals to weight or volume of solute divided by weight or volume of solution times 1 million. And now let's go to colligative properties of solutions. Colligative properties of solutions have 4 types, which are freezing point depression, boiling point elevation, osmotic pressure, and vapor pressure lowering. What is colligative properties of solution? In chemistry, colligative properties of solutions are those properties of solutions that depends on the ratio of the number of solute particles to the number of solvent particles in a solution, but not on the nature of the chemical species present. What are the 4 colligative properties of solutions? First, vapor pressure lowering. The vapor pressure of a pure solvent is greater than the vapor pressure of a solution containing a non-volatile liquid. This lowered vapor pressure leads to boiling point elevation, wherein, when something is volatile, it actually able to evaporate very quickly. For example, adding a pinch of salt to a cup of water makes the water freeze at a lower temperature than it normally would. Boil at a higher temperature, have a lower vapor pressure, and changes its osmotic pressure. Boiling point elevation. It is dependent on the presence of dissolved particles and their number, but not their identity. On the other hand, it is an effect of the dilution of the solvent in the presence of a solute. For example, spreading salt on an icy road melts the ice. A solute generally raises the boiling point of a solvent, which is called boiling point elevation. For example, adding antifreeze to the water in a car radiator prevents the water from boiling. Then, freezing point depression. It is observed in solutions that results from the introduction of solute molecules to a solvent. The freezing points of solutions are all lower than that of the pure solvent, and it is also directly proportional to the molality of the solute. For example, a very common example of this phenomenon in everyday life is salting on the roads in water. Pure water freezes at 0 degrees Celsius. However, by mixing in salt, the freezing point of this mixture of water and salt will drop well below 0. This is why salt is used to keep roads free from ice. And lastly, osmotic pressure. Osmotic pressure is higher when molar concentration is higher or temperature is higher, and the molecular weight is lower. Then, osmotic pressure depends mainly on the molar concentration or molarity of a solution. And also, osmotic pressure is a colligative property, meaning that the property depends on the concentration of the solute but not on its identity. An example of this is a cucumber placed in brine solution loses water and becomes a pickle. A limp carrot placed in water becomes firm because water enters by osmosis. And eating large quantities of salty food causes retention of water and swelling of tissues, or what we call edema. And that would be all. Thank you for your attention. And once again, I am Jadil Yasran from Bachelor of Secondary Education, major in Science, Section 1-2A of Group 6. Thank you!